Welcome to the chapter area related to circles. So here in this figure it is given ABC is a right angled in which angle A is equal to 90 degrees. AB and AC are given and semicircles are drawn on AB, BC and AC. So this is a semicircle on AB, this is a semicircle on AC, and on BC this will be the semicircle. Now we have to find the area of the shaded region. So this is a very common question which you can see in your tests and all. So here first we will find, we have to find the area of the semicircle with BC as a diameter, but we do not have the length of BC. But we have these as these sides and this is a right angle. So using Pythagoras theorem, BC is equal to, in triangle ABC, BC is equal to root of AB squared plus AC squared. So that is equal to root of 21 squared plus 28 squared. So this is equal to 441 plus 784. Try to remember the squares of these numbers at least till 30. It will be useful for you. It's very easy to remember also. So it is 1225 is equal to 35. Now area of the shaded region will be, so we have to find the area of the full portion, that is area of the triangle plus area of the semicircle, that is the full part including this. Then again area of this part. So area of triangle plus area of this semicircle plus the area of the semicircle. So you will get the full figure. Now we have to reduce the area of this semicircle with BC as the diameter, then you will get the area of the shaded region. So area of shaded portion is equal to area of triangle ABC plus area of semicircle with AB as diameter plus area of semicircle with AC as diameter, then minus area of semicircle with BC as diameter. So this is equal to, area of triangle ABC will be half BH, so half into 21 into 28 plus area of the semicircle with AB as the diameter, so half into, or pi r squared by 2, so pi into 21 by 2 pi r squared, so it's a semicircle, so by 2 plus pi, again here r will be 28 by 2 whole squared by 2 minus, again it is a semicircle, so pi into, we know BC is equal to 35, so 35 by 2 pi r squared by 2. So here we will take pi by 2 in all these three. So this will be 14 into 21, that becomes 294. Then I'll take pi by 2 outside. Then I'll get 441 by 4 plus 28 squared will be 784 by 4 minus 35 is 1225 by 4. So you take the LCM. Here you will get this as adding everything, you will get 1225 minus 1225. So this is answer is 0. This is 0. So your answer is 294 centimeter squared. So try to take out this common factor here and do, because pi by 2 is involved in everything, so that your calculation becomes much easier. Otherwise you will be losing a lot of time in your exam. So please, when you are practicing, please practice in these methods where your calculations becomes easier. So it's just practice only. So here it is given ABCD is a trapezium and AB is parallel to CD and AB is equal to 18, CD is equal to 32 and the distance between AB and CD is 14 is given. The circles of equal radius 7 centimeters with centers A, B, C and D have been drawn. Find the area of the shaded region of the figure. So here we have to find the area of the trapezium minus area of the 4 sectors. But here to find the area of the sector you need the angle, but the angle is not given separately. So we did a similar problem earlier with a triangle. So we will write A by 360 into pi r squared, B by 360 into pi r squared. So A plus B plus C plus D, you will put it as 360 and then we can solve this problem. So area of the shaded region is equal to area of trapezium minus area of 4 sectors. So area of trapezium will be half into AB plus CD into height minus, now area of the 4 sectors will be theta by 360 into pi r squared will be, so it is radius, circles of equal radius 7 centimeters. So it is pi theta by 360 into pi r squared is 7 squared. So theta 1, so we'll write this as A1 plus A2 by, not A1, A plus B by 360 into pi r squared plus C by 360 into pi r squared plus D by 360 into pi r squared. So now this is half into 18 plus 32 into h is 14 minus, now pi r squared by 360 we will take it out. So it is 49 pi by 360 into, so it is A plus B plus C plus D. We know the sum of all the angles in a quadrilateral is a quadrilateral or a trapezium, anything, it is a 360. So this will be, so 50 into 7 is 350 minus 49 pi by 360 into, this is 360. So you are left with 350 minus 49, pi is 22 by 7, the 7 it goes, so it is 350 minus 154, so that is equal to 196 centimeter squared. So here it is given a square OABC is inscribed in a quadrant. So this is also OPBQ is a quadrant. OPBQ is a quadrant. And OABC is a square. Now this to find the shaded region, area of the quadrant minus area of the square, you will get the area of the shaded portion. So now to find the area of the quadrant, it is pi r squared by 4. So we have to get the area of the radius of the quadrant, but only we have been given only the side of the square 21. That is OA is 21, but we do not know OP. OP or OB are all radius. OP, OB, OQ are all radius, but we do not have the radius of the quadrant. So now we have to find the radius. So this is a square, so this is 90. So join OB. So in a square we know the diagonal is equal to root 2a in a square. So OB is equal to root 2 into 21 root 2. How do you get this? Suppose this is a triangle, this is x, and suppose this is A and this is A, so this is 90, so we have to find this. So this will be, suppose this is O, A and B, so OB is equal to root of A squared plus A squared, so just root of 2A squared, so that is A root 2 or root 2A. That's how you get this. So OB is equal to 21 root 2. Now we can find the area. So area of shaded portion is equal to area of quadrant minus area of square. So area of quadrant is equal to pi r squared by 4. So now OB is equal to, we got 21 root 2, so pi r squared is 21 root 2 the whole squared, pi r squared by 4 minus area of the square is 21 squared. So we will take here 21 squared, we will take out that so that our calculation becomes easier. So you are left with pi by 4, so 22 by 7 we will write it out. Then 4 in the denominator, 21 squared has gone out. So here again root 2 the whole squared will be 2 minus 21 squared has gone out, so it is 1. So this will be 2, 11 by 7 minus 1. So take out the LCM. So it will be 21 into 21 into 11 by, so 7, 11 minus 7, 4 by 7. So again you can, I am doing this calculation so that you understand how easily you can finish off this problem. So you are left with if you do this 21 into 12, you get it as 252 centimeter squared. So in this problem, it is slightly different. Here the circle, the square was inside the quadrant. Now you have the quadrant inside the square. So they have given OA is equal to 7. So if you see, the length of the square and the radius of the quadrant is same. So now here you don't have to find any radius of the quadrant separately or the side of the square separately. So that is the difference between both the problems. So area of the square is equal to, so to find this portion, area of the square minus area of the quadrant, quadrant. We will get the area of the shaded region. So area of the square will be 7 squared minus area of quadrant will be pi into pi r squared. So pi r squared by 4. So again this is 49 minus 22 by 7, then 4 in the denominator into 49. So taking the LCM, 98 minus 77 by 2, that is equal to 21 by 2 is equal to 10.5 centimeter squared.